Hi, my name is Dan Schumacher, and I'm going to show you my board game market segmentation project. A little bit about myself is that I love board games. I play them with my friends as much as I can, and in 2018, I had the opportunity to go to Korea to study Go at a professional player's house. Our primary goal of market segmentation is to find and describe people who buy board games so that we can sell them more board games. It's a win-win for everybody. The data that we'll be using is an NCS survey that contains 65,000 rows and 25,000 columns, where the rows are the survey variables and the columns are the individuals responding to the survey. Lots of cool stuff to look at here. Here's our method. We'll be doing a little bit of planning by selecting variables. We'll do combining to make abstract construct variables. We'll do some clustering. We'll do gap analysis and compare that to the clustering, and then we will explain our groups using our descriptor variables. So, as we said, our target variable is going to be whether or not the individual bought a board game in the last 12 months. Here are our abstract constructs. We'll talk more about these later, but for now, know that one of them is called the host and one of them is called cost conscious. Here are our single drivers. We'll use these again for clustering. You'll see them more as we go on. And here are our descriptor variables. We have some demographics, some attitudinal variables, websites used, and purchases made in the last 12 months. Let's talk about principal component analysis, which is where we take similar variables and combine them into one mega variable. And this can give us more information than the single variables by themselves. So when we perform PCA, we need to look at the eigenvalues and make sure that only, in our case, two factors have an eigenvalue of greater than one. And this is because we have two factors, hopefully. The cost-conscious variables we plugged in and the host variables that we plugged in. Let's see how we did. Excellent. So as you can see, only the first two factors have an eigenvalue greater than 1. But that's not all. First, we need to look at the loading variables. So when we see how the individual variables loaded across each factor, we run into a messy situation. We see that special offers is a little ambiguous with only a 0.09 difference between the two. Compare this to careful money, which is 0.04 to 0.8, a big distance. So I ended up removing that, so there was no ambiguity in where our variables were loading on our factors. Now that we have our mega variables, or our abstract constructs as they're called, we need to do k-means clustering. This is an unsupervised machine learning algorithm for grouping similar people together. And it allows us to cluster unlabeled data. I have some examples for you if that's confusing. Here's the first one, which looks at, in this case, whether a person likes dogs or whether a person likes cats. Here's the unlabeled data, and then using the machine learning algorithm, we're able to label the data into 3 groups: the yellow group, the pink group, and the green group. The way that k-means works is that it's trying to maximize the distance between the centroids, which are those circles in the middle of each colored group, while minimizing the amount of distance of each color to its centroid. However, k-means is not limited to just 2D space. Here's a 3D example where you can see we're looking at annual income, spending score, and age, and we're able to make 5 clusters based on where people fall in that 3D space. In our case, we're going to be looking at 6 variables or axes used for clustering. Here they are here, and you'll see that they include our 2 abstract constructs we created. So when we perform k-means, we're going to be looking at the first local max of the CCC and pseudo F. Hopefully we'll have a non-negative CCC, although small negative values are okay. And we want a large R squared, although as we have more clusters, the R squared will always go up, and so it's only kind of used as a tiebreaker. Let's see our different trials. Trial number 1, I wasn't a fan of, only because the first local max is at 3 clusters, and that's not as many clusters as I'd like to explain the thousands of variables and individuals in our data. So let's move on from that. Cluster number 2, I did like. We have a secondary max at k equals 7, as well as close to a secondary max at the pseudo f. Also, the CCC at k equals 7 is positive, which is a good thing. Here's trial number 3. I also like this because it has a strong primary maximum. And although the CCC is a little bit negative, it's not a deal breaker. It's not such a large value that it's going to mess things up. So how do we know whether trial 2 or trial 3 is a better model? We can do that by calculating the number of ties and dividing it by the total number of combinations. Here's the formula to do that. But if that's confusing, we have a chart right here. So in the host column, you can see that cluster 5 and cluster 6 are considered tied because they're less than 0.1 distance between the two of them. And this whole column contains 3 ties. We do that for all of the columns and then divide by the total number of combinations in our data set, 147. So with 7 clusters, we have a tie ratio of 0.14. Not bad. But compared to having 4 clusters, they have a tie ratio of 0.08. So therefore, model number 2, trial number 2, is our best model. But wait, what if gap analysis has a different result? So gap analysis is an alternative to k-means, and where k-means is trying to minimize the distance within a cluster and maximize the distance between clusters, gap analysis determines the number of clusters by subtracting the pooled sum of squares from a reference data set from the pooled within sum of squares from our actual data set. Let's see how gap analysis was performed, how it performed. And just like trial number 1, I didn't like it because it's only telling us to use 2 clusters. And that's not a lot when you're trying to explain the demographics and the opinions of all of these thousands of people. So I decided to ditch it and go back to k-means model number 2 as my final model. Let's get into the results. So we're going to explain the groups using the descriptors. Here they are again. And when we plug them in, this is what we get for our means. This is a kind of a messy table, so let's look at it a little more closely. This is cluster number 1. You'll see that only 8% of people in this cluster bought board games. It's the only male dominant cluster, and it's the youngest cluster. I found this to be really surprising because I would fall into this category as a young man, but I buy board games, so I thought there would be more board game purchases in this category. Cluster number 2 is our most female group, and it has the highest buying board games percentage. More on them in just a second. Cluster number 3 bought a medium amount of more games, but that's not where the meat of our results are. So we're going to look at cluster number 4. And this is very similar to cluster number 2. It's a little bit more Hispanic than cluster number 2. And so but besides that, they're very similar. So I wanted to look at the cluster means. And you'll see that cluster 4 is more hosty than cluster 2. It's much more cost conscious than cluster 2. It likes control of people and resources more than cluster 2. And it's a little bit less family driven than cluster 2. Here's some key takeaways. Our female clusters purchase more board games than male clusters. Board game use Facebook a lot more than other groups. Board gamers use Barnes & Noble a little bit more than other groups. And board gamers typically make between $45,000 and $50,000 per year. So here are 2 strategies I have made for selling board games. The first one is to make a cheap game about controlling resources or people and advertise it to females, maybe Hispanic females, on Facebook. This would target cluster number 4. We could also target cluster number 2 by making a high-end family-oriented game and advertise it to females on Facebook. Thank you so much. I hope you enjoyed my presentation. And if you have any questions, please reach out to me. Thanks so much.